Yeah, our designer for the hackathon in a meeting took one look at our like poster, which is, you know, we're calling it the metaHackathon. And she said the very first thing she said, and Discordian said the same thing, which is, could you not have the word meta in it, because we all hate Facebook. So she's going to be in charge of collecting a list of other words for hackathon. So I think the rule is it can't be more than 3 words or like 15 characters or something. So what is everybody, let's get everybody's like hot take. Like, what's another way, how do you describe a hackathon in as few words as possible as a icebreaker?
It's a grind, right? I don't know. I think of it as like, I don't know, maybe grind isn't a good word though.
Well, like, you need a couple words. Like if you just said it's a grind, then like people don't know it's for coders or for designers. But
yeah,
code grind, building grind, that's not too fun. Okay, you think, Kevin, think. Soumya, your turn.
Yeah, building friends and building something cool together.
Okay, that's a little bit wordy, but we can work with that. Xian.
I think it's like crack. I mean, okay. It really depends on the hackathon, but for ETH Global specifically, it's only 36 hours, and then most people don't sleep like Saturday night. I don't know, it's like an adrenaline rush, right? You have a short amount of time to get something done. So you can't procrastinate.
Well, some people will do that.
That's true.
They're the goblins. Those are the goblins and the trolls. Alex, what do you've ordered the Hackathon Survival Guide book, Alex?
I did. It's coming tomorrow.
Nice.
I haven't done one, but it's like prototyping vomit. It's a forced concept generation. It's quick and dirty.
Nice. Prototyping vomit festival. Cool. Danjo will be here in a couple minutes, and yeah, I think we've got a small group, and I don't know exactly what Kevin has in store for us today, but interactivity and questions are welcome, and because it's just us. So he's a superstar rock star developer advocate. I'm just not going to introduce him too much. I'll let his skills stand for himself, but thanks to his workshop on Scaffold-eth, I just used Scaffold-eth as my environment for working on the smart contract in my last hackathon. I had some bugs and stuff, but I actually had a lot of fun using Scaffold-eth, and there's so much resources in the repo. And if you just like take the 30 minutes to go all the way through the videos and read all the way through the documentation, most of the answers are already there for you, but you may hit a wall and then have to solve the problem yourself. But that's kind of the fun of it. So without further ado, Mr. Crypto Mastery.
All right, thanks, Tippy. Yeah, so I figure I'll just share my screen here just to start out, and we'll kind of go over just like a really brief understanding of like what it means to actually build on Ethereum or on Web3. And then we'll actually do like kind of a walkthrough and a workshop, and I'll try to see if you guys can follow along if you want to. You don't necessarily have to, but really it's kind of just like a teaser of kind of like how you interact with smart contracts and build smart contracts in a development environment. So, but yes, I want it to be interactive. So I'm gonna try to just get through these slides real quick, and then really just open it up for you guys to kind of like ask questions as we go along, and to give feedback. So like if something's not clear, just stop me. This is my contact info, by the way. So if you guys scan this with your phone, you can save my contact info. Pretty much all my socials are on there, Telegram, good stuff like that. Yeah, my name's Kevin. I work full-time for Nginx. If you guys aren't familiar with Nginx, it's like the #1 most used web server reverse proxy. But I also am an advocate for building on Web3, building on Ethereum. And I recently, over the last couple of years, have found actually Scaffold-eth to be a huge part of my journey into like building on Ethereum. So I actually started doing workshops and talks for it, and it became part of the Build Guild, which I'm going to talk about as well here in a little bit, which Build Guild's like a group of developers that build on Ethereum and use Scaffold-eth. And yeah, I'm just really excited about teaching. I also have a nonprofit. I also help out with a Solidity developer track called Growick or at Growick. And I also do photography and filmmaking. So you'll see me at like crypto events shooting photos a lot as well. Okay, so if you do want to follow along, if you guys are like listening asynchronously right now, what you can do is make sure you have these 3 things on your computer. So you'll need a copy of Git, obviously, to check out the repository. You'll need Node.js 16 or higher, and you'll need a copy of Yarn. And you need to have the newest version of Yarn. Don't use like an old version of Yarn if you're using Linux. You might have some issues. So just make sure you install the newest version of Yarn. I would just install the newest version of Node as well, which is like 18 or above or something like that. But you need to have at least 16. If it's before 16, it won't work. So that's important. So go ahead and install that stuff if you want to. I'm just going to give a brief overview for those people that are like kind of new to Web3 and these concepts, and really like explain like what it really means to build on Web3. So I think before getting into like what Web3 is and what it stands for, it's good to understand like where the web came from and where we're kind of at today. So, you know, the very first iteration of the web was like Web 1.0. It's just this real basic concept, right? Where like static files are being served from servers. There was no really dynamic information. Everything was simple. There maybe was some JavaScript, but really it was just a means for broadcasting information, right? Web 2, which is kind of where we're at right now, really, as far as like mainstream web goes, is a little bit more complex. It's this idea of like dynamic content. You have databases, you have network storage that's shared across clusters. You have lots of more protocols that have been built that allow you to extend the value of the internet, right, where we're at. We also have seen information be more flowing in between services. This gave kind of birth to this concept of APIs, right? And everything just kind of gets a little bit more complex in this kind of Web 2 kind of ecosystem, right? Web 3 is just this completely new concept of building applications in a decentralized way, right? So decentralized, blockchain-based providers or dApps are connecting to each other using RPC connections. Everything is permissionless in the sense that if you have a public key cryptography pair, you can interact with that blockchain. And the blockchain is secure in the sense that it's secured by whatever consensus algorithm that is kind of securing it. And all of the logic or the access to that logic is pretty much immutable and available to everyone. It's open. If you have a public key cryptography pair, you can interact with that blockchain and you can make changes to the state of the applications that are sitting on there. And this makes it somewhat censorship resistant, right? Everything is on the blockchain. Again, users connect to dApps, decentralized applications, which also might be stored in a blockchain-based or decentralized file protocol. And then if you have like a service like a provider that interacts with the blockchain, it usually will connect to nodes for you, and it will kind of act as like that intermediary. So you might have heard of like Infura or Alchemy or Moralis. These are all providers that provide like an entry point into the blockchain, usually via an API or an SDK, or they might be able to provide a node as a service as well, where they're acting as a node on the network, right? Coinbase does this as another example. Any questions about this? Because I know this, for anyone new to blockchain, this is usually kind of the confusing part in really understanding like how some of this works.
Hey, Kevin. I think you guys all introduced yourselves. I'm Dan or Danjo. Hey.
Hey,
I
Dan.
do have a question about that actually. As far as like decentralization goes, I use Alchemy and Infura all the time, but I've often thought like, well, what if their API goes down? I mean, isn't that a centralized point into a decentralized network?
100%. Yeah, 100%.
Okay.
There's been some rumors about like Infura actually decentralizing their provider layer. So there's some rumors about something like that. And yeah, that's why really like the true like decentralized way is actually to run your own node, right? You'll hear that with pretty much any blockchain. Like Bitcoiners will say that all the time, like, okay, that's great, you like Bitcoin, but you need to run your own node. Same thing goes for Ethereum. It's not easy to run your own node right now. It's somewhat difficult. So there's definitely a barrier to entry to do that. But yeah, if you want to be fully like Web3 decentralized, then yes, you should run your own node. Until there's kind of like a move to like for providers to be more decentralized, which like I said, I think that's coming. Yeah, we're kind of relying on those providers in some senses. And even like some of the stuff I'm going to show today, we use a provider, it just makes it easy. But you know, this might be like, I don't know if you're familiar with like this concept of like multi-cloud. If you're designing an application, you know, you design it in a multi-cloud way where you have like multi-cloud strategy. I think you can do the same kind of thing with a blockchain application. You can do like a multi-provider strategy, right? Have backups, right? In case one provider goes down, you have access to another provider or something in that fashion. That's, like I said, probably not the Web3 way to do it, but yeah. Does that make sense?
Yeah, that actually answers it pretty well because I've been working a bit with Immutable X lately, and everything works through an API with them. And I was like, well, isn't that just Web 2? And yeah, the way they do it is like tons of redundancies, essentially, where if one of the servers goes down, then there's like 8 more that'll pop up and things like that. Thanks for answering that though.
Yeah, no problem. Thanks for answering the question. This is the kind of questions I'd like to get through. So thank you. Anybody else have a comment or thoughts on this? Makes kind of sense.
Yeah. This is great. I just want to check in with the group. Is anybody planning on following along with the coding parts that are coming up? And I haven't heard from, I know Shen probably has all those things, but Alex, are you planning to follow along? And have you had any trouble getting Git, Node.js, and Yarn package manager? That's sort of, I just want to know what to expect here.
I'm going to try and follow along.
Okay, do you have those prerequisites ready to go?
Yeah, I just got Yarn.
Nice. Okay. All right.
Awesome. And I'm going to paste like a link to my Bitbucket here in the chat so that you guys can open that up in the meantime. 1 second here. All right, open the chat. Okay, well, I'll get to it in a second. Let's keep moving along. Okay, so if you're a developer, you're going to build on Web3, right? You write your front end or your decentralized application in something like JavaScript, HTML, React, Next.js, Vue.js, whatever you pick as your framework and your language. Maybe you're just using vanilla JavaScript, whatever, it doesn't matter. The point is you build your app, you deploy your app on a decentralized file service, or you try to, at least if you want to be truly a Web3 application. So this could be like IPFS, which is the interplanetary file system. You could also deploy it to something like Arweave, which is like more of a permanent file storage. Same thing with Filecoin. There's a lot of different options for that. But your backend application is written in a smart contract. Okay, so smart contracts are the backbone to what drives your application. It's your backend, right? And it's infrastructure essentially as code. And it is distributed all across the entire network of nodes on the network, okay? And it is stored in a state or in a block that is available to all of the other participants in the network so that they can access and make transactions against your smart contract, okay? Everything that you do inside that smart contract is self-executing, and the logic is handled inside of that contract. So you define variables there, you update variables with functions, and we're going to get to that a little bit later. And the cool thing is that when you do something like deploying a smart contract, you remove the need for any intermediary, because the network consensus of the network and the ability to interact with that smart contract using public key cryptography ensures the security of transactions between the user and the smart contract back to another user, right? And so it also allows these smart contracts to act as a bank and store value of the native currency that you're writing the contract in. And it also allows you to really just interact with that smart contract using an API library like Web3.js or Ethers.js. These smart contracts are written in usually like specialized languages. Solidity is what we're going to talk about today, but there's also Viper. Some smart contracts are written in Rust. And these are smart contracts that are written in plain text in this high-level language, and then it's compiled down into bytecode, which we're not going to get too much into, but it's important to understand that that's the process. When you compile your smart contract, it gets compiled down into bytecode and deployed to the network in that sense. And again, providers or APIs can interact with the with the application. And then as you interact with your application, it builds state changes to those blocks, and they're verified, right? Just like a normal blockchain would. This is kind of what Solidity looks like. It's high level. You don't really need to understand Solidity super well right away, but definitely understand that it's just a high level language. It's object orientated. It has a importance around optimization, because when you're deploying a smart contract on the network, you have to pay upfront for that storage price, and you have to pay for any kind of like state that you initially set, or any kind of variables or functions that you define, all have to be stored on the blockchain. And so you have to pay for that upfront. And it's very important that you optimize the smart contract and use as minimal amount of characters and minimal amount of functions and variables, and just optimize your contract to save as much money on that cost to deploy it. And when you do that, you use gas. We're not going to get too much into gas, but it's important to understand that gas is what powers the network. And specifically, we're talking about Ethereum virtual machine. And again, after you take your smart contract, it's compiled down into bytecode. And in order to read it, it becomes, when it's compiled down into that bytecode, it's pretty much unreadable by human eye, unless you're like really trained at like what opcodes and how to read that bytecode. You need an ABI. And the cool thing about Scaffold-eth is it's going to build the API or take the API for you and inject it into your front end, because your front end needs a copy of the ABI to be able to read those functions and make changes to the and call the functions that are available and whatnot. And we're going to show what that looks like in a little bit. So any questions about this real quick?
Yeah, I got a quick question.
Yeah.
Just about the optimization. You even mentioned that even like the number of characters, is that like the function naming by being terse with your naming can save a little bit? Or is it that if you're saving an array to size it to the exact size that it's going to need rather than making it dynamic? Is that what?
Both.
Wow.
Yeah, because if you name a variable, I don't know, apples and oranges, it's going to have to take up all of those characters on the blockchain all the way across the network. So you wouldn't want to define a variable name as apples and oranges. You would just want to do AAO or something like that, shorten it up, right? Use as little amount of storage on the blockchain.
Awesome. That's
short and sweet.
Nice. Yeah.
Yep.
Do comments play a part in that as well?
Mm-hmm.
Yeah.
Yep.
Okay. I figured, but I just wanted to make sure.
Yep. Because you're storing that, right? So it's compiled down. Yep. At least I don't think, I'm pretty sure, yeah, that they consider storage. You probably would pull all that stuff out before you do that. That's a good question. I usually see people pull out their comments. So, okay, so Scaffold-eth is what I'm talking about today. We're going to walk through it. we're going to show how you build a simple dApp. It's open source, so you can just Google Scaffold-eth. It'll be the first thing that comes up. And it's got a lot of good content already written and created for it on YouTube. There's a docs page. There's also a cool like a learning platform called Speedrun Ethereum, which will walk you through using Scaffold-eth to build some cool stuff. So that's a good starting point, is if you've kind of got started with Solidity a little bit and you feel a little pretty comfortable, go to speedrunethereum.com, and that will kind of walk you through on how to build different kinds of dApps or decentralized applications. Again, we talked about you need Git, Node.js, and Yarn. When you do, the cool thing about Yarn is like a package manager, but it's also a scripting tool. So it allows you to create short Yarn commands for doing different things on your project. And it's already comes with a Yarn file that defines all of the packages that you need installed. So when you do a Yarn install, it's going to install all the dependencies. And the first thing it's going to put on there is Hardhat. Hardhat is a virtualized Ethereum virtual machine. So it's like a virtual machine that you run locally that pretends basically to be an Ethereum virtual network or a virtual machine, and it allows you to interact with the blockchain in a way like as if you were dealing with a test net or a mainnet. So it installs that. It also installs React for you, and it also installs Solidity for you. Well, it gives you a smart contract and all the compilers that you need pretty much to get going. So to get set up, you do a git checkout or a git clone to clone the repository. You do a Yarn install. It's going to install all the dependencies, including Hardhat. You do a Yarn chain to install Hardhat, or to start Hardhat. You do a Yarn start to start up a React, and you do a Yarn deploy to deploy your contracts. So this is kind of like the flow of things. And then as you start testing your smart contracts ability and your front end, you'll start seeing blocks form and stuff like that. So this is kind of like the overall flow. I'll share these slides so you guys have these, and I'm going to walk you guys through it right now. But this is just kind of so you know what it looks like from a developer environment. Speedrunethereum.com, don't forget that. There's a developer chat for Scaffold-eth. You can also Google that. It's also available on the GitHub page. There's also a docs page, so docs.scaffoldeth.io, which is really good. All right, let's go through it. So let me hide these panels.
While you're doing that, since I've already done a basic Scaffold-eth implementation, is it cool if I just CD into my Scaffold D&D, because I didn't really change much on the back end, or would it be better if I followed along? Like,
no, it's fine. You can just go into the directory you already had and just I just usually reset the repo. So I just do like a git reset. I do like git reset, -- hard head like that, and just reset the directory and then pull it down, and you'll get the new version of the repository. Okay, so
the terminal thing you have called?
Oh, I use tmux. It's called tmux. Yeah. So I use tmux because it is, allows you to have like multiple windows open and you can move them around. So like if I'm here, I can like this, Control B, and I can adjust them. And I can also flip around between the different windows. You can just do it in 3 different windows. You don't have to have tmux, but I just like using tmux because it's just super clean.
yeah.
Okay. Yeah, so we'll close this. So Scaffold-eth, all the instructions are available in the GitHub. So again, it's going to be the first step is you're going to clone the repository, which I've already gone ahead and done. So it's already here. And then you go into that directory and you'll do a Yarn install. And then I've already also done that. So let's just see and make sure Yarn install. And we'll see if we installed all those dependencies, and we did, so we're good. This will take about a minute to do, so you'll want to let that kind of run. And then the next one is going to do a Yarn chain. So we're going to do that here. We're going to do Yarn chain. So you always have 3 windows open when you're using Scaffold-eth. That's because the first window is Hardhat. The second window is React, and then the third window is kind of where you're doing your deploys. So you can see that I've already started hard hat. It's pretty much ready to go. It's running on localhost. The next thing is I'm going to start up React. So I'm going to go into a second window, same directory, and do yarn start. It's going to spin up React on localhost 3000, which that's going to take about a minute to start. So we'll let that sit. And then the next one is we're going to do a yarn deploy. Okay. So yarn deploy is going to take the smart contract that's there. It's a real basic one, and it's going to deploy it to hard hat. And we can see here that now we're getting some calls to the Ethereum virtual machine. We see that there's an address that was called, transactions. We see there's some gas was used. Now we see some React started, and now we see some other contract calls. So we can see like a console output on this top left corner that shows us like real time, like what's going on with the virtual machine, Ethereum virtual machine. And then here we can see if there's any syntax errors with React. But what's important is here, we deployed the smart contract to this address, and it tells us how much gas we used. Again, gas is like the native currency. It's the lowest denominal, well, it's not the lowest, but it's the GUE, the amount of gas that you use to power some kind of change on the Ethereum virtual machine. So when you first deploy your contract, you got to pay the gas to deploy it. So we deployed it, and it cost $390,000 in 390 GUE in gas, 390,000 GUE. And it tells us how long it took. Let's take a look at, first of all, what the front end looks like. So this is what Scaffold-eth is. Scaffold-eth essentially is, again, it's all built on React, and it's got this kind of like cool night mode you can switch back and forth between. And you see these tabs that are here. Let's make it a little bit bigger. You guys can see that there's these tabs. This first one, app home, is like where you build your app. So if you're going to start building out your front end in React or Next.js or whatever framework you decide to use, you'll plug it into here. This debug contracts folder is really the magic sauce of Scaffold-eth. And you'll see here that we have a copy of a contract. It's called your contract. We have the address that's here, which should match this address, which it does. So if we look at it, 0x5bf, 0x5bf. So sorry, FB. And then we can see if it has any funds in it. We can see there's a variable defined, and we can see a function as well that allows us to change that variable. Then we can also see up here that we have a wallet that's built in. It's called a burner wallet. It's this like wallet that you can use inside of the browser that keeps track of your crypto, as opposed to having to use MetaMask. You can just use this burner wallet, and I can just grab some funds from the faucet by clicking that little button, and it sends a transaction, and it pulls some funds from the hard hat nodes, and it puts them inside my burner wallet. And if I open up another browser and go to the same app, I'll still have access to that because it's inside the browser. But if I come over here and I do file, new incognito window, and go to localhost 3000, I'm going to get a new burner wallet because I'm in this kind of incognito mode now, right? Now I have this little purple blocky dude, and I have this little green blocky dude, and they're kind of like different identities, right? Because they're different wallet addresses. So now I can grab some funds for this wallet. And that allows me later on, when I want to start testing things, I can have multiple identities, and I can try to make changes to the contract. So let's come back to that. And we could also connect to MetaMask if we wanted to, but we're not going to do that. We're just going to use these burner wallets because they're really easy. You don't have to worry about any nonce errors or anything like that. If we want more money, like this is only 0.01 ETH, I could grab the address here, and I could come down here to this wallet here, and I could grab some more funds. So let's grab $100, I don't know, like this, and send it. So now I have $111, right? And I could just grab as much as I want. There's over, there's 10,000 Ether in here. So there's $1.1 million in ETH that we can play around with. But let's take a look at the smart contract, because that's what I want to kind of show you guys today. Let's open up. So I'm going to open up inside of Atom, the directory structure for the smart contracts. And I want to show you really quick. There's this packages folder, and then there's two folders in there. There's the hard hat folder, and there's the React folder. Those are like the most important parts of Scaffold-eth. The hard hat folder is where the contracts are. So this is going to be where your contract is that we're seeing here inside of this UI. So you can see what we have here. We have an event, which is like an event for Ethereum. We have a string, which is just a variable, and we have a function that allows us to update the variable. So I could come over here and I could just say building permissionless apps like this, save it. And then I could come over here and redo my deploy, and I'll do a reset too. So I'll do yarn deploy -- reset, and that's going to force a new contract to be deployed. And so now if I come back, we'll see that my change has been made. So I came in here, made a change to my smart contract, redeployed it, and then boom, here's my update. But what if I want to update it through here, right? Let's say I want to take this and I want to change the state using this function. Well, I can do that because there's a function here that takes in a new purpose. It's publicly, it's a payable, and it allows me to set the new purpose and then emit a log and emit an event. So this is really good because I can make a change. So I can say meta hackathon, like that, and then I can send. And I can update the state here as well. So I paid a little bit of gas to do that, okay? And so this is where you can start testing. If I come over here and I can refresh and see if it came through, but let's start building some kind of small change to our smart contract, okay? So the first thing you might learn when you're building on Ethereum is you might want to do like access control. Like you want to require like, hey, if someone's going to interact with my smart contract for doing certain things, I want to require a certain rule that says you must be a certain person or a wallet address. So what I could do is I could take this address that I have here, and I could come over here and define a new variable. So we'll go address public, the boss equals, and then we'll do this. So then we'll come over here, we'll say, all right, in order to call this purpose, we're gonna require that the message sender, which is the person that's sending the transaction that calls this function, is equal to the boss. Otherwise you are not the boss, or something like this. And then we're gonna save that, okay? So we're just defining an address and then requiring it on this function. So let's come over here and redeploy. So this is kind of like the loop you get in when you start building smart contracts. And the cool thing is that, again, everything is already kind of set up for you with Scaffold-eth, and it's automatically doing this and getting you prototyping really quickly. And so now we can see we have a new variable called boss, and we have this address that should match what we have here. And if I come over here to this purple account, which is not the boss, right? I have this purple one, which does not match. And I say foo bar like this, something like that, and hit send, it's going to tell me that I'm not the boss. I can't call that function, okay? But if I come over here and I say, yeah, I am the boss, right? And hit send, it's going to let me. So this is kind of like a first iteration of access control. So again, this is kind of like the loop you get in. You make a change with your smart contract. You come over here, you deploy those changes, then you go into the UI and you start kind of testing your assumptions of how you're building out the smart contract. Really quick, I want to pause there and see if people are following along. Anyone stuck? You don't have to be. Yep, go ahead.
Yeah, I'm not stuck. I was a little behind it, and I'm now like setting in the require statement. But the question I was going to ask was a little bit before, when you were starting with a very baseline. You've got a contract with a purpose, and you could hard code it and you can update it. And let's look at the front end updating it. Could you take a second to zoom in on the code of the front end to show us, like, we could also hard code the front end to send in a piece of information, and that,
yeah,
right? And like that part is kind of a little mysterious. Like, how does it know all the functions and like how to display that to the user?
Yes, that's very good. Yeah, that is a little abstracted. So I probably won't get into like how that is generated, but what's important to understand is that I told you before, when you write a smart contract and you compile it down into bytecode and you deploy it to the virtual machine, in order for your front end to understand it, you get a copy of what's called the ABI. It's the application binary interface. And it's just basically like a map that has everything you need to be able to kind of interact with that, right? And so if you go under artifacts and you go to, let's see, where is it at? Contracts, your contract, and then we go right here to your contract.json. So hard hat, artifacts, contracts, your contract.sol, your contract.json. it will show you what that ABI looks like. And so we can come down here, and if we wanted to, we could see kind of what that looks like. Here's some inputs. One of them is called set purpose, and we can see that it's payable and it's a function, right? And then this is the kind of like the lower level bytecode for that, okay? And so what happens is Scaffold-eth reads in this file and basically says, oh, cool, okay, well, we have some events, we have some functions, we have some variables. Let's kind of just automatically build this one component, right? So let's go down into that real quick. So let's go to the React app. So inside of React, inside of the source file, and then inside of app.jsx is like basically everything that you're seeing here, like the entire app that is Scaffold-eth, right? So app.jsx is the entry point for React, right? And yes, there's a lot of convoluted code in here, but what's important to know is that here under views, we'll see a copy of, so first of all, home JSX. So home is this here, everything that you're seeing here. The home is where you would build your app. But I think what's most important for people that are that know React or are a little bit familiar is this example UI. Okay, so example UI, let's click on it real quick. It has all sorts of different UI components that are already written for certain things. So like there's one that reads the purpose. There's one that has a empty field with a button that says set purpose. We have one that keeps track of the address that we're connected as. We have one that allows us to do ENS resolution, which is like DNS for Ethereum. We have one that has the balance, et cetera, et cetera. So if you want to get an example of how to interact with your smart contract, well, you can just come over here and say, okay, cool. Here we have a set new purpose function, which has an input. And so we could just take this, and then here's the button that allows us to make a change. So we could just grab like whatever code we need from here, copy it from example UI into our home JSX as well, and just kind of start building out our UI that way. Does that make sense?
Yeah, that's exactly, because I'm just trying to imagine if I was like going to use this as a jumping off point for my front end, for example. Is this stuff that I could use? Is it not stuff that I can use? Like maybe my very first, if I added the boss variable in there, maybe the first thing I would want to do is like update the example UI to like also display the boss somehow, and then get that displayed.
Right. So yeah, so we could grab like, I think if we grab this, let's try it because I haven't tried this in a while, but let's grab this. This is the UI and then an example. So let's go to home JSX and let's just get rid of like pretty much everything else here because we don't want any of this stuff pretty much. Let's just grab this and let's paste it there. Let's save it. Let's see if it works. Oh, great. So we might have some like undefined. So we would have to go through here and import. We might have to grab like everything that's at the top of probably example UI right here. So we could just make sure that we have all this stuff as well. Let's see if that works. Let's see if we don't get any issues. Okay, use state from React. Let's try this.
Oh, it's
This
because
is
you
like
have it, maybe you have it twice there.
Do I?
Line.
Oh yeah, you're right. Oh yeah, you're right. Okay. Well, so you would have to work through this stuff, but yeah, essentially these are just kind of like examples for how you do it. Ideally, you would probably write your own kind of like UI code here. But yeah, you would want to kind of go through and like fine touch and like redo all that stuff. Let me just take these out real quick so we go back to the demo. But yes, that's a good question. Let me just get rid of this. Okay, so now it's blank. Okay, but yes, you can use these as reference, and yeah, that's good feedback though. I think yeah, it would be better if we had maybe like more content on like how to kind of like start building your front end app. But it's important to know that you'll just put everything inside of here, right?
Yeah, I mean, it's still a great startup, but like I did things where like I put in my own contract in there and it's got a different file name,
Mhm.
and then that breaks a bunch of things. And then I'm like zooming around looking for the words your contract and renaming them haphazardly. Which I've
Yeah.
done, like I did that 3 or 6 months ago, the last time I did Scaffold-eth. I went, and it's fun, and it's like reintroducing me to where the code is. But with you here, I thought maybe I could just ask you where the stuff to pay attention to is. And it looks like that's a really good shortcut, home and the example UI.
Yes, and let's see if I can find this. There's also a adding second contract scaffolded. Let me see if I can find it. There's also a walkthrough on how to add a second contract. Here we go.
Ooh.
Adding a new contract. So this goes in. So I think for you, like if you're going to add a second one, then this kind of walks you through like what you name your deployment script,
In the deployment
where
script,
you
yeah.
add the component, where you add a certain component to add an additional component, stuff like that. Yeah, good one. So this
Just a
all
quick
pays to
question. Oh, sorry.
Mhm.
Just a quick
No, you're good.
question. I noticed when you were doing I'm the boss with both of the things, it automatically updated to the text that you updated when you sent the transaction.
Mhm.
Does it by default just does it just call that function again from the contract, or is it listening for an event like with WebSockets or something like with Alchemy?
That's a good question. So I think that, well, it's not using Alchemy for that. That's just probably listening for events locally. So if we go, let me close this. So if we go to like debug contracts, and so I think what's happening is if I click the send button, it's refreshing automatically because it knows that there was a message that's being, so there's some kind of like use state or something like that that's happening. But if you go here to example UI, there are some events here which are being parsed. So there's like, this is how you would do just normal like listening for events on Ethereum. So there's an example that shows you how to do that. You basically are listening for like those emits that are happening. And so if I come over here and I say foo like this and hit set purpose, then it should be parsing. There it goes. See, it automatically grabbed it here. So if I go like, let me just send a bunch like that. There they go. So there's a way to like parse all of the events, but it's not the ideal way to do parsing of events. Or I should say, it's not the most optimal way. The most optimal way to like parse your events is actually to put them in some kind of like API. So if you've ever heard of the graph, have you heard of the graph before?
Yeah.
So the graph is awesome, and it actually Scaffold-eth comes with support for the graph out of the box. There's just a couple more steps to set it up. It's all right here. So this kind of talks about it. Like, so if you want to use the event listener, you can, but it's kind of clunky. And it can be kind of, like I said, if there's lots of events in your smart contract, it can be clunky. So you can instead use the graph. This implementation of the graph is all running locally in Docker. So you can spin up a graph node. By running yarn graph node, you can create a subgraph, and then you can ship your subgraph to the Docker instance. And then instead of deploying with yarn deploy, you deploy with yarn deploy and graph, which will publish your subgraph and deploy your smart contract. And then there's an example here that you can kind of mess with and change some functions and see how instead of using the event listener, you use an API to do that. And there's also a GraphQL Explorer here so that you can make a query over GraphQL to that API data and get those events as one single API call, which is a lot more efficient. Hopefully that makes sense.
Yeah, that's cool. Thanks.
Yeah, no worries. Okay, so let's keep going a little bit. So if you guys have kind of like been following along, let me hide these meeting controls real quick. Okay, if you guys have been following around a little bit, we created a variable, or I should say we created a variable address, and we did a require statement. But something else you'll learn about with Solidity is you actually probably don't want to hard code things like this. It's actually better to do what's called inheritance of another smart contract that allows you to do access control. So one thing you'll know or learn with Solidity is you can import another smart contract by just doing import command. So the kind of like the standard kind of implementations of different protocols and different kind of patterns are written by OpenZeppelin. OpenZeppelin is a company that kind of is specialized in like security and smart contract auditing and stuff like that. So you can just import ownable. And then we can say, okay, well, your contract is ownable. So we can inherit everything that's inside of this smart contract. So we just imported it, inherited it, and then we get access to, the minute we do that, we get access to all of the functions inside there. So let me deploy the changes so we can see what we get access to. So we abstracted away our stuff we had put in there before. We abstracted away the require statement, and instead we just imported ownable and then inherited ownable, right? And then what happens here? So look at our smart contract. We get all sorts of new fields. We get an owner variable. We get a new renounce ownership function here. We get a transfer ownership function, which allows us to transfer ownership of the contract. But what's interesting is this owner address does not match our wallet, right? It doesn't match any of the wallets we have under control. So who is this address? This address is the very, very first account owned by Hardhat. So what we need to do is we need to transfer the ownership of the smart contract at the time that we deploy it, because currently we do not want to use this this particular address because we don't have access to the private key. So how do we do that? So inside of Hardhat, there is a deploy folder. You'll see it here. And this deploy folder is essentially a JavaScript deployment script that requires Hardhat ethers, and it gets a copy of the contract. So it sets all of the rules for the deployment here. And we'll see right here that we get the deployer from the named accounts. So the very first named account. So that is the very first named account in Hardhat. And we deploy with that using here. So here's where we actually deploy our smart contract. So because we can deploy from here, we can also get access to all of these functions that are available here. And what's the one we want? Well, we want transfer ownership. So what we can do is, and it's already written right here, we can copy this from the deploy script, paste it down here. And then let's grab the address we have access to, the private key, which is here. And let's paste it in here. So what this is going to do is it's going to deploy our contract like it normally would. And by the way, if you wanted to pass anything inside of the constructor, so the constructor is, sorry, right here. The constructor allows you to do things during the deploy, like maybe you want to set the name of a NFT or you want to set a certain supply. You could pass that into the constructor here as a variable. If you want to do that, that's what this args is for right here. So I could say args, I don't know, Doge, and then I could set like some kind of supply as 77777 or something like that. You could pass stuff into the constructor that way. That's just good to know. So, but yeah, so what we're doing is we're deploying our contract, and then we're transferring the contract using this transfer ownership, which is that function that's available here, and it takes in a new address. And so we're going to use this address here, and then we're going to save it, and we're going to redeploy. Okay, so now let's check it out and see, there we go. So now we have our contract, we have a new instance of the contract, and now we're the actual owner. So because we're the actual owner, we can then take this function that we had written before, let's close out of this, and we get access to the functions that I just talked about, but we also get functions, or we get the modifiers. So a modifier is like kind of a set of rules that you can write for a function. And so instead of using set purpose here, we could use only owner, which is a modifier that allows you to do the same, basically the same thing as the require statement that we were writing here before, where we said like message.sender needs to equal whatever. Well, it's basically the same thing, but it's already written in the form of a modifier. So we can just use that if we wanted to. We're actually not going to do that, but it's good to just know that we have access to the smart contract. And we have access to, well, we are the owner of the smart contract, and we have access to transfer it. And we also have the ability to renounce our ownership if we wanted to as well. Like we could say send and then get rid of it. And then now no one owns the contract. See? So the reason why you would renounce an ownership is if you wanted to like instill trust in your smart contract and just show that it's going to live forever and no one will be able to access the funds inside of it. That's kind of like what people do, is they'll renounce and let go of the smart contract. Since we lost it, let's go ahead and redeploy our smart contract so we get access again. There we go. So now we have a new contract and now we have access to it. I want to show a couple things real quick that just show like kind of iteration. So we notice that we have a function here that's payable, right? Why don't we do something more interesting, like require that, let's require that the value sent in the transaction, so sorry, message.value is equal to 0.01 ether. Otherwise, we're going to say, send me some money or something like that. So now we're going to have something interesting happen here. Is we have this payable function, and we're going to require someone actually, if they want to change the purpose, they have to send some money. Okay, so let's redeploy that. And let's go back to our UI. And now let's try to change the function to whatever we want. Okay, hackathon, like this. And hit send. It's going to tell me, well, I need to send some money. So let's put in 0.01 ETH. And now what's important to know is when you're transacting on Ethereum, you're actually sending the lowest denominational value of currency, which is WEI, W-E-I, WEI. So one ether is times, oh sorry, one WEI is times, one ether is times 10 to the 18th power equal to WEI. So if you click this little green button, it will do that math for you. So it'll multiply it by 10 and then give it to the power of 18, and it will tell you what that is in WEI. So 0.01 ETH is this much WEI, right? And so it's important to understand that when you're doing transactions, you need to do the transactions in WEI. So you wouldn't want your user to have to type in that stuff. So this is just kind of a little developer tool that allows you to not have to do the math, and you can start kind of like making it user friendly. You would probably want to do this with what's called ethers.js. There's a way to convert automatically from WEI to ether. Obviously, you wouldn't want your users to type in WEI. You'd want them to type in ETH. So let's hit send. So now we have the hackathon that we updated, and then now you'll see what happens here. We have the contract has value. So we're actually storing value in the contract. So there's something missing though. We don't have any way to get the money out. So now it's kind of like a black hole. So what we would want to do next, and we're just going to write that real quick, is we're going to make a withdraw function. We're going to call it withdrawal. Withdraw, right? And then we're going to make it public. And we're going to set a Boolean called success. Otherwise, we won't. And if someone calls this, what we're going to do is say the message.sender.call, and then we're going to pass in a value of the smart contract's balance. So we're going to say address of this smart contract's balance, like this, like that. Boom. Okay, I think that's right. So this is a public function. Anyone can call it, but let's make it only owner. Let's only let the owner call this function because it's going to be able to withdraw all the funds from the contract. We don't want anyone to do that. We only want the owner to be able to do that. So we're going to set a Boolean called success. We're going to, if it's successful, we're going to call message.sender.call, and we're going to get, so call is anytime you want to transfer funds from a smart contract to a wallet or to an externally owned account, you do a call. Not necessarily need to know that right now, but that's just why I'm doing that. And then the value is passed into this kind of like JSON object. And we are going to grab the address of this smart contract's balance. Okay, so let's save that and deploy. And now let's try to do it again. So let's change the purpose to metaHackathon like this. Do it. Now we got some funds in the contract. So now if I come over here to this purple guy, and we see that we have some funds here, and we refresh real quick. And now if I come over here and try to withdraw, it's going to tell me that I'm not the owner, right? But if I come over here, which I am the owner, I should be able to withdraw and I just got all the funds out of the contract and they went back to my balance. So you can see how we kind of built this simple app that just doesn't do much. It just lets you change a state, but you have to pay some value. And then we have it acting as a contract. We could do one more small interesting thing is we could take the smart contract like this, and we could make one small change like this. Price is equal to price times 101 divided by 100. So let's increase it by 1% each time. Let's save that. So just with one little small tweak, we're going to require that the price, oh, did I do that wrong? Your price times. Oh, because I don't have price defined. So here I'm hard coding the price. What we could do is go like this instead, price, and then we can go, sorry, uint public price equal 0.01 ether like this. So we're hard code the price up here, reference it here, and then change the state of that variable here. Hit save. Let's try that one more time. Here's the code. And by the way, I set a link in chat to like kind of all this code that I'm typing right now. That worked. Okay, so now let's try it again. So now if I come over here, it shows me what the price is in ETH. And it also shows me, so if I go foo bar like this, sorry, like that, hit send. There we go. Now we can see that the price has been adjusted, right? And it's increased by 1%. And if I say hello, and try to send it, it's going to tell me that I need to send more money because I didn't send enough. And so I need to figure out what that new calculation of way is. So with just one little small change, we will have to make some changes to our smart contract front end as well. And there we go. And so we'll start building a smart contract that is starting to collect large amounts of value. Maybe we're increasing some percentage over time and starting to build some kind of like curve into the smart contract. So I know we're like right on time. So I want to see if anyone has questions, see if that makes sense, see if anyone wants me to talk about anything else. You guys are welcome to hang out for a bit. I don't have anywhere I have to be, so.
I got a question.
Yeah.
I followed most of it conceptually. The renounce function, that's from the Open Zeppelin one.
Mm-hmm.
Right. So I'm assuming there's just something in there that reliably destroys access.
Yeah. So
How's
just
that? How that
basically it transfers the ownership to contract 0000000. So it just basically throws away. So the pattern is like, if you're not owner 0, you can't get access to smart contract ever again. And there is no owner 0. So contract 0x00000 just does not exist. So when I hit send, it renounces that to that owner 0. And that kind of reliably just throws away access, because unless you somehow had access to owner's account 0, then you wouldn't be able to do anything with the smart contract.
Yeah, cool. It's simpler than I imagined it was, because I've seen that before, but I didn't know it was that simple.
Yeah. So
yeah, it's just changing the state to all zeros. Yeah. Mm-hmm.
The Open Zeppelin is giving you transfer ownership and the modifier only owner, which you stick on things that you don't want to let other people do, like take all the money out of the thing. And then the renounce ownership function is just basically a function that calls the transfer owner function for you and sets it automatically to 0. So then it's trustworthily secure, right?
Yeah, that makes sense.
Yep, correct.
Good question, Alex. Did you follow along, by the way? Were you able to get your contracts deploying with the reset and all that?
Definitely not, but I followed conceptually.
Okay.
Yeah, I apologize. It's hard to like do it slow, but I did link in the chat like a link to all of my docs. Sorry, the Bitbucket, which has like all the videos I've ever done this talk before. So you guys can follow along and watch that like really slow, or it might be a good option for you if you weren't able to follow along right now. Plus this is recorded, so Tippy can share it with you as well.
That's right. Yeah, that deploy -- reset is something I wasn't doing 4 days ago. And it was because I may not have noticed it in your previous video, and I was like rushing. So I was like, I'm trying to do this, just get the thing I want. And then sometimes you miss a new, if you don't do it with that reset. Yeah.
Yeah, so you can see how it's failing if I don't use the reset. I think it's because I did some kind of transfer on the ownership maybe or something. Yeah. So yeah, yarn deploy -s reset. Personally, I think yarn deploy should be just hard coded to reset because I think every single time you deploy, you should be starting from scratch anyway. So
Yeah, is
but
reset
yeah, I
just
was-
doing hard hat clean?
You know, we can take a look. It's doing this right here. So hard hat deploy. Oh yeah, so it's doing hard hat x deploy export all. Yeah, I don't know what export all does. And oh, I think that exports the ABI, right? And then just resets. So I'm not sure. I don't even know what command this does. We could actually just look it up real quick.
I mean, I guess I just assumed that it like gets rid of your all your artifacts and cache and everything.
Yeah.
Just so you
Mhm.
start nice and fresh. Cause like if you were like if you had 2 contracts and then you remove one and then you're only deploying one, but you don't, so then you don't want the artifacts of the one that you decided to remove, then maybe that reset sort of does that.
Yeah, I think this is what it's doing here. Yeah, reset clean, reset hard hat. Yeah,
Nice.
yeah. I don't know why it's not loading, but yeah. Stack profile is down. Okay. So hopefully that was valuable for you guys. I will do another workshop for the meta hackathon, which will be more focused around like starting points too as well. So like I didn't really touch on it, but like under master here. So if you go to Scaffold-eth and go here, you can search for like, I don't know, let's say you want to do an ERC 1155. There's an example already for that. So you can use that as a starting point, right? For if you're going to build something on 1155. Same thing goes for like, I don't know, 721. I think there's one as well. Oh, there's also another repository. So if you go to Scaffold-eth's GitHub, there's this challenges repo, which is everything around speedrun Ethereum, but then there's Scaffold-eth examples. And it has some other ones here. So if we do that, we can type NFT and we can see all the different NFT examples that are there. So there's lots of different starting points. There's an SVG NFT example, which is pretty cool. This is like an ERC 721 one. This is 1155. Yeah, optimistic NFTs. There's also a lot of cool, like Loogies is another one that was created by Austin Griffith, which is like SVG drawing Loogies. They're like these little like they look like loogies basically. They're like little slime balls, but it shows you how to build a NFT that will draw those, right, using an SVG file. So there's a lot of cool starting points here, which is good for hackathons, right? Because you can just kind of build off of someone else's work, kind of go from there.
Yeah, and ask questions where there's a community that might answer them. Like I was rushed for time when I was doing I forked the Chainlink VRF NFT, and I think it doesn't use VRF2. There's a new VRF which has some slightly different stuffs. But I did consult that code for myself. You know, I was checking that code.
Yeah.
And if I had planned my time better and was doing it a week earlier, I could have just been like, issue, question, this doesn't work because it's VRF2, or taken the time, which I did do, to figure out in the docs, and ideally make my own PR on your open source repo and like update the VRF to the newer VRF, right? Would that be a better play?
Mm-hmm. Yeah, possibly. Yeah. I will say that like you can ask in the Telegram chat, because sometimes there's builds floating around that are on other people's GitHubs as well too. So it could be someone may have already done that as well. But yeah, I'm not familiar with the VRF example, but that's the Chainlink VRF, right?
Yeah,
it's like for doing
random stuff,
randomness or something. Yeah, randomness. Yeah. Yeah, maybe we need to think about like a special build. Did you get it working?
My contract worked, but I wasn't able to use Scaffold-eth in the right way to test it. So what I was doing would I would just be I got it deployed the first time, and I was like, okay, there's no more errors. Now then I took it into Remix, and I was just using Remix, but I wish I had like one thing that I really wish was there's a getting it from its on local host to getting it on a test network and being verified on the test network. That flow, I was like looking through it in the last minute, and I was like, fuck it, no verification. I don't care. I'm just doing it the way I know. So like sometimes in that last minute rush, you're like not being as smart as you should be with your like resources.
Yeah, I didn't really have time because we only had an hour. I would normally go through actually deploying to a test net and actually verifying the smart contract as well. So maybe I can do that for the next one.
Yeah, for sure.
That's a good, yeah, we'll make sure we go all the way through and deploy to a test net. Yeah.
Awesome.
Basically, you can do a yarn deploy -- network and then the name of the network. So you could do network Goerli like this. The thing is that you need to yarn run generate first to create a mnemonic that is custom, because you don't want to use the hard hat account because it's a compromised private key. So what you do is you create a new account using yarn run generate, and then we do yarn account. It will basically create a QR code for us here that we can either scan or we can just send some funds to the deployer account. It's right here. And you can fund it with just a little bit of ETH, whatever you need to cover your deployment. And then you can do a yarn deploy -- network Goerli, and it would deploy it as long as there was funds there. Obviously, this would fail right now because it's going to tell me that I don't have enough funds, and there's also nothing to compile. So see, it's going to fail. But if there was funds in my wallet, I would just have instantly been able to deploy to Goerli. And then I can also do yarn verify, put the address of the smart contract, so I could grab it if I had it, like if
it
it
just
was valid,
gives it to you.
like, and then I could do network Goerli here like that, and that would verify my smart contract as well. So you can do everything from the command line.
Yeah, that's what I wish I had set up. That's the next hackathon. If I ever do one again, I may be off hackathons forever.
Cool. Well, I hope that was useful, guys. I'll be at the next metaHackathon for sure. I'll do like, I think we talked about 2 different ones. So we'll do like a 1-hour one, like more intro to Web3 and Solidity, and then we'll do another one that's 1 hour like hackathon, Scaffold-eth and how it helps the hackathons, right?
Yeah, nice. Any feedback before? Should I stop recording? Anybody want to throw anything in there for the future? 3, 2, 1. POAPs.